This is part 3 of the series Logarithmic, Exponential, and Other Transcendental Functions. In the last video, we took a look at using the properties of logarithms to simplify logarithmic expressions with the intent of being able to differentiate and integrate these functions easier. We're going to start this video with a real brief description of the natural number, which is a fundamental part of the natural logarithm. The definition of the natural number is a direct extension of the definition of natural log. If you recall, the definition of natural log was the natural log of x is equal to the integral from 1 to x of 1 over t dt. And here we're just replacing the x with the natural number e. So that's the fundamental definition of the natural number. If you were to press this into your calculator, you would end up with 2.7182818, and so on and so forth. So that's just a basic definition of natural number. Now what we're going to do is we're going to use these properties that we looked at in the last video and this definition of the natural number to look at doing logarithmic differentiation. Hopefully you'll recall when we went through the derivation of the natural log function using the limit definition of a derivative, we said that the derivative with respect to x of natural log of x ends up being 1 over x. And the natural extension of that is if u is any differentiable function of x, then the derivative of the natural log of u, that differentiable function of x, is simply 1 over u times the derivative of u. And this is all, of course, assuming that u is greater than 0 because natural log is only defined for positive values. So let's go ahead and use this to solve some basic problems. Here we have 4 basic problems, and what I would encourage you to do is go ahead and pause the video and attempt each problem in turn, and then start the video back up to compare your results with what I get, just to make sure that you get this concept down. The more practice you get, the easier this becomes. So let's start with number 1. Go ahead and pause the video, and when you're ready, commence. Here we have the derivative of natural log of 2x. This is 2x is a differentiable function of x, so the derivative with respect to x of the natural log of 2x is just 1 over u times the derivative of u, which is 2. Cancel out the 2's, and we have 1 over x. Alright, go ahead and give number 2 a try, and when you're ready, start back up. Alright, the derivative with respect to x of the natural log of x squared plus 1 is, again, this is a differentiable function of x. We have 1 over u, which is x squared plus 1, times the derivative of this denominator, which is simply 2x. This does not simplify in any way, so we just join the terms. And there you have it. All right, go ahead and give number 3 a try and start up when you're ready. Okay, now this one is going to be the product rule. Not the product rule for logarithms, but the product rule for differentiation. So the derivative with respect to x of x times the natural log of x is going to be u times the derivative of v, which is 1 over x. The derivative of x is just 1, so this is u dv, plus v, which is ln of x du, and derivative of x is just 1. Let's go ahead and simplify these. This x and this x go to 1, so we simply have 1 plus the natural log of x. All right, now give number 4 a shot. Okay. The derivative with respect to x of the natural log of x cubed. This is just going to be the power rule. And we have 1 over x cubed times the derivative of x cubed, which is 3x squared. And then we have a cancellation here. This x squared goes away, and this 3 goes to a 1 because these are canceling out. This gives us 3 over x. Now before we move on, I would like to take a look at another example relating to this one. What if this had actually been the following? What if it would have been that? What would you have done? Give it a try and see what you come up with. Alright, now you should see, hopefully, that this is just an inner function and an outer function. So this is simply going to be the chain rule. So the derivative with respect to x of this, I'm not going to rewrite this derivative because I'm running out of space over here. It's just going to be the chain rule. So it's 3 times the inner piece squared times the derivative of the inner piece. And as we know, the derivative of ln of x is simply 1 over x. And what we have here then is 3 ln of x squared over x. So hopefully you can see here that the primary issue with logarithmic differentiation is to make sure you know what you're working with. In this case, instead of this being my u term, having the whole thing enclosed in parentheses and raised to a power. Also, notice in this one, you could have, rather than take this as u, we could have simplified this using the power rule of logarithms. We could have taken that 3 and pulled it out front and started with the following. We could have started with 3 times the natural log of x. And then when we take the derivative of this is just the constant multiple rule. So it's just 3 times the derivative of ln of x, which is 1 over x. And that's simply the same as this. 3 times 1 is 3, 1 times x is 3 over x. So it's very important that you understand what it is you're working with before you start doing your differentiation. All right, let's take a look at a different example. Go ahead and give this one a try. All right. Now what we have here is we're going to convert this before we start. This is the natural log of x plus 1 to the 1/2 power. And I'm going to pull that out front. So we have 1/2 natural log of x plus 1. Now we can go ahead and differentiate this. And this is going to be 1/2 1 over x plus 1. And the derivative of that inside piece is just 1. So we have 1 over 2 times x plus 1. Alright, let's go ahead and try another problem. So give this one a shot, and I'll come back in a second. To work this problem, what we're going to want to do is expand this expression using logarithmic expansion. So let's start out by saying this is the natural log. Let's do the numerator first. X times x squared plus 1 squared minus the denominator. That's a 1/2. All right, now we're going to continue expanding this guy. Here we have a product. So that's going to be natural log of x plus the natural log of this piece minus, we're going to pull that 1/2 out with the power rule. Okay, now we just have to pull this 2 out front and we'll be ready to roll. Just rewrite this piece. Okay, now let's start taking the derivative. So the derivative of this first piece is 1 over x plus, here's the constant multiple rule, so we'll have 2 times 1 over u x squared plus 1 times the derivative of u, which is 2x, and then minus 1/2. This is going to be 1 over 2x to the third minus 1 times the derivative of this piece, which is 6x squared. Now we can simplify this piece. Here we have 2 times 2, which is 4. So rewriting this first one. And then this piece, well, we've got this times this whole thing. So let's just put a parenthesis around this thing. But these two are going to cancel out. So we're going to have 6 divided by 2 is 3x squared on top. And then this piece on the bottom. All right, let's go ahead and do one more problem. It's not necessary to combine these terms, by the way, to get one common denominator or anything like that, because we never know really what we're going to be using this for. So let's just leave it in this form. So let's look at a fourth problem. You're welcome to give this problem a shot, but I'm just going to walk through it one step at a time just to save time and aggravation on your part. Hopefully this won't cause some frustration. Now the first thing we're going to do, since we don't have a natural log in here, I could just go ahead and differentiate this as normal, but I could improve the process by taking the natural log of both sides. So that's what I'm going to do first. So that's all I did, was take the natural log of both sides. Now the next step is I'm going to expand this right side. So now I expanded this right side in 2 steps. And now I'm going to take the derivative of the left side and then the derivative of the right side. So for this first one, the derivative of ln of y is 1 over y prime, because we're assuming that y is a differentiable function of x. So this is just the chain rule, implicit differentiation. The derivative of this piece is 2 times 1 over x minus 2, which is just 2 over x minus 2. And the derivative of this is 1/2 times 1 over x squared plus 1, and the derivative of this piece is 2x. These 2's cancel out, and we're left with this piece. We're not done yet because we've got to solve for y prime, so we're going to multiply both sides by y. And now we have to substitute this value of y in this place, and we're going to write that up here. And now we're going to combine this into one fraction with a common denominator. So here we've multiplied this by this by this with that sign, and this by this. Then we combined our terms in the numerator, and then we simplified. Now that's all that's left, is we have a cancellation here, and we're going to combine this denominator here. Take some time and study this if you need to, and I will talk to you in the next video.